Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we'll be learning about how to prove lines parallel. So let's get started with the following do now. What is the value of x such that line L is parallel to line M in the figure shown below? As you can see here, we have some of the angles in terms of x. So what is the relationship between this angle here? So let's draw this angle, and this angle. Well, it turns out that these two angles are the alternate exterior angles. Notice that we don't know if the lines are parallel yet. However, we know that in order to make the lines parallel, those two alternate exterior angles must be equal in measure. So what we can do here is set both of these expressions equal to each other. Namely, 7x minus 65 is equal to 5x minus 5. So this means that if we add 65 on both sides and subtract 5x, we obtain that 2x is equal to 60. Dividing 2 on both sides gives us an x value of equal to 30. Now, how do we know that these two lines L and M are parallel now? Well, let's substitute x equal to 30 into those angle expressions. So if we substitute 30 into 7x minus 65, we obtain an angle of 145 degrees. And if we substitute 30 into 5x minus 5, we also get the same angle of 145 degrees. So what can we say here now? We're also noticing that the 145 degrees that are created by these two lines and the transversal are the alternate exterior angles. And these alternate exterior angles are congruent, and therefore the lines must be parallel. So this was one of the theorems that I developed in one of my previous YouTube videos. Let's review these theorems. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. If two parallel lines are cut by a transversal, then corresponding angles are congruent. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. And if two parallel lines are cut by transversal, then alternate exterior angles are congruent. The last one was kind of related, but a little bit different. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one as well. So for all of these theorems, except the last one, we have conditional statements. If P, then Q, in which the hypothesis P is two parallel lines. So those are the givens. And the conclusion is the Q, right? That the alternate interior angle are congruent, corresponding angles are congruent, same side interior angles are supplementary, or the alternate exterior angles are congruent. Again, we have a conditional statement with hypothesis P and conclusion Q. So here we just looked at parallel line theorems in which the hypothesis was two parallel lines, which is the given, and the conclusion is that the angles are either congruent or supplementary. So the question is the converse true as well? Basically, what happens, or how do we formulate the theorems if Q, then P? Our goal is to first formulate the converse of those given conditional theorem statements and to determine if these are true or not. So let's look at the first one. It says here, if two parallel lines are cut by transversal, then alternate interior angles are congruent. So what would be the hypothesis in this case now if we take the converse of that? Well, the hypothesis would be that we're given that the alternate interior angles are congruent. And we want to prove that the lines are parallel, and that's the conclusion. So the converse would be if two lines are cut by transversal and alternate interior angles are congruent, then the two lines are parallel. Notice that the hypothesis starts off with if two lines are cut by transversal. We're not saying that these two lines are parallel yet until the conclusion. Again, the hypothesis is alternate interior angles are congruent. and the conclusion is two lines are parallel. Now, the converse of the second statement states, if two lines are cut by a transversal and corresponding angles are congruent, then the two lines are parallel. The third statement would be, if two lines are cut by transversal and same side interior angles are supplementary, then the two lines are parallel. And again, that is the converse of the third theorem shown here on the left side. And the converse of the last theorem would be, if two lines are cut by transversal and alternate exterior angles are congruent, then the two lines are parallel. So the question is, do the converse of these theorems work as well? Are these also true as well? Well, let's look at an example. Let's say we have two lines here. We don't know if they're parallel or not, but we know that the alternate interior angles here, for example, these two angles, are congruent. The question is it true that the two lines, let's call these lines L and M and transversal T, is it true that lines L and M are parallel? Well, the answer is yes, it must be true as well. Well, it turns out that they're all true, and that's why we call them the converse of the parallel line theorems. Even though we call them like this, you still need to write them all out in the statement reason table, as shown here. Okay, so let's look at an example now. Let's say that segment AB bisects angle CAD as shown in the figure. So let's annotate that in the diagram really quick. So here we have these two angles to be congruent because we have an angle bisector. We're also given that angle CAB is congruent to angle CBA. We want to prove that these two lines here, or segments, are parallel. So how do we do that? So let's first set up a statement reason table now. And for the first statement, we can state that segment AB bisects angle CAD as a given. What does that allow us to say now? We can say that angle CAB is congruent to angle DAB because of the definition of angle bisector. For step 3, we're given that angle CAB is congruent to angle CBA. And maybe we can already see something here. For step 2 and 3, we know that angle CAB is congruent to angle DAB and angle CAB is congruent to angle CBA. So what can we say about angle DAB and angle CBA? We can say that angle DAB is congruent to angle CBA because of the substitution or transitive property. Now, if we look at the diagram here, what do we notice? We notice that we're dealing with alternate interior angles. So which lines in this case are the ones that are parallel and which one is the transversal? Well, sometimes it helps if we extend these lines. So if we extend the lines, we can clearly see that the transversal now is line AB. And the lines that must be parallel are lines BC and line AD, respectively. Also notice that the diagram here is not drawn to scale. So therefore, we can conclude that line AD is parallel to line BC, because if two lines are cut by transversal and alternate interior angles are congruent, then the two lines are parallel. So let's look at an example now involving snowmaking and parallel lines. The problem states as follows. To shoot the snow as far as possible, each snowmaker below is set at a 45-degree angle. The axles of the snowmakers are parallel. It is possible to prove that the barrels of the snowmakers are also parallel, but the proof is difficult in 3 dimensions. To simplify the problem, think of the illustration as a flat image on a piece of paper. The axles and barrels are represented in the diagram on the right. Lines J and L2 intersect at point C. So here we have the given that line L is parallel to line 2, and also that measure of angle A is equal to measure of angle B, which is equal to 45 degrees. How do we prove that line J is parallel to line K? To complete the proof, let's set up a statement reason table. Then we state the first given that line L1 is parallel to line L2. Okay, so then we ask ourselves, is there anything we can conclude from that first given here? Remember, we want to use the givens only when needed in a statement reason table. So there is something we can conclude here. If we look at these angles here in the diagram, we can see a relationship between supplementary angles and vertical angles. So let's look at it a little closer here. So let me zoom in the image. There you go. So we have the image here zoomed in. So if we look at this angle here, right, that's 45 degrees. We know that that angle here is supplementary to this angle, okay? So let me name that angle by adding a point here. Let's call this point D. So we know that angle A is supplementary to angle ACD, right? Because we're given that line L and line 2 are parallel. So from that, we also know that this angle here must be equal in measure to angle ACD. So let me place another point here called point E, so we can refer them as angle BCE and angle ACD that are equal in measure because they're vertical angles. Then if we look at this angle B here, we know that angle B is also supplementary to angle BCE, and therefore lines J and K are parallel. So all we need to do now is write everything down in the statement reason table. So let's do that. So here we can say angle A and angle ACD are supplementary because if two parallel lines are cut by transversal, then same side interior angles are supplementary. Notice that here the transversal is ray ACE, or we can call it just line J, okay? So that's the transversal. Okay, so since they're supplementary, what can we say here? We can say that measure of angle A plus measure of angle ACD is equal to 180 because of the definition of supplementary angles. But we also know from the given that measure of angle A is 45 degrees. So we can just simply substitute to obtain that 45 plus measure of angle ACD is equal to 180. So we can now find the measure of angle ACD by subtracting 45 on both sides. So here we obtain a measure of angle ACD to be equal to 135. But we know that angle ACD and angle BCE are vertical angles from the definition, and therefore those two vertical angles, angle ACD and angle BCE, must be equal in measure. So from step 6, we know that the measure of angle ACD is 135, but that is also equal to measure of angle BCE. Therefore, for step 9, we can say that the measure of angle BCE is equal to 135 by the substitution postulate. We could have also used the transitive property here, which would have also worked. So what do we notice here at this point? Well, let's write down the last given, that measure of angle B is equal to 45. So what can we say about measure of angle BCE and measure of angle B? They also add up to 180, and therefore they must be supplementary. So we can say that angle BCE and angle B are supplementary from its definition. Notice that these are also the same side interior angles of line J and K that are cut by transversal of segment CB. So therefore these lines have to be parallel. And to prove that line J is parallel to line K, we simply use the converse of the theorem that we developed today. If two lines are cut by transversal and same side interior angles are supplementary, then the two lines are parallel. So that's basically it for this proof. That's also it for today's lesson. And again, thank you for watching and have a wonderful day.